Convection currents. According to the theory of plate tectonics, the lithosphere is composed of several large plates that float on the asthenosphere, which is the liquid layer in the Earth's mantle. The plates move as a result of convection currents in the Earth's mantle under the lithosphere. Convection is the movement of liquid material that is heated from underneath, then rises and cools on top. Hot material has a lower density and rises, while cold material has a higher density and thus sinks. Where hot material flows upwards and downwards, the plates slide past each other or separate. Where cold materials sink to the bottom. The theory of continental drift. When you look carefully at our world map, especially the continents, they almost look like puzzle pieces, like they fit together. Let me introduce you to Alfred Wegener. Alfred Wegener is a German meteorologist who lived in the late 1800s and early 1900s, and as a weather person, a scientist of the atmosphere. He spent a lot of time looking in maps, and so he noticed this strange shape phenomenon. The problem is, he couldn't get past it. He devoted his whole life to it. He came up with a radical theory that suggested the continents were actually once connected and somehow drift apart to where they are today. He came out and said, I think the continents are moving. He devoted his life, his whole career to studying this and coming up with proofs about this radical idea. In fact, Wagner didn't just think the continents were moving. He actually believed that there was a time that they were all connected and they have since drifted apart to their current locations, and has came up with a name for that supercontinent that existed in the past. He called it Pangaea or Pangaea, that he believed existed 250 million years ago. Pangaea is actually an appropriate name because it is a Greek term that means entire Earth. People thought that Wegener was a little insane, so if he was going to make a headway with this idea, he had to come up with evidences. So we are going to take a look at four pieces of evidence that Wegener put together to prove to the public that the continents have in fact drifted. Let's take a look at this first piece of evidence. It is simply the observation that the continents appear to fit together, especially the east coast of South America and west coast of Africa. As simple as that, Wegener didn't believe that this could be simply a coincidence. So, this is evidence number one. We will call it the apparent fit of the continents. Let's take a look at the second evidence. So he became interested with fossils and other evidence of prehistoric life. He became particularly interested with Mesosaurus, an ancient reptile that lived only in shallow fresh water. What's interesting is that there are only two places in the world where we can find fossils of this freshwater creature. One place is the east coast of South America, and the other one is the west coast of Africa. There were possible solutions. One, Mesosaurus learned how to fly, but that's not likely because Mesosaurus could not fly, and they could have swum across, but the distance is just too great, and they can't survive in salt water. So what Wegener said, while the Mesosaurus roamed the land, Africa and South America were connected, and they were able to freely walk across the land masses. And after going extinct, the land masses were torn apart, carrying the fossils of what would become South America and Africa. Wegener also found out that there were other organisms that lived in the past that has similar fossil distributions that suggest that the continents were once together. So that is our evidence number two. We call it the fossil correlation. But Wegener knew he needed a stronger case, so he became fascinated by rocks and geologic structures. He found a really interesting pattern, not unlike what he found with fossils. If we go back to our world map, look at North Atlantic. Look at the mountain ranges in the northeastern United States and northern Europe. They match up perfectly. They are made of the same type of rock and the same age of rock. So that becomes evidence number three. We call it rock and mountain correlation. Let's take a look at the last evidence. This could probably be the most complex of them all. He returned into his roots as a meteorologist, and he became to look at past climate data, meaning he looked at evidence of cold and warm weather in different parts of the world, and he found something fascinating. He first looked into glaciers, and glaciers are only to be found in cold parts of the earth. They are only restricted to highest mountain tops, and of course, the North and South poles. What's interesting with glaciers is that they move over the rock beneath. They leave evidence in the form of patches, and we call this glacial striations. So how does this relate to climate? Well, if we look at our world map, if you look on the present day tropical rainforest of South America and Africa, you will find glacial striations here in these two regions. It means that these continents were not always in their warm equatorial regions like they are now. They were once down near the South Pole, where it could have been cold enough to have glaciers, and they have since drifted apart. But Wagner wanted more from this climate data, and so he began to explore a little deeper, and that's when he came across with this type of sedimentary rock called the bituminous coal. Bituminous coal is a fossil fuel that is made of compacted plants remains. So picture tropical plant like this dying on this forest floor and getting compressed over millions of years to form coal. Let's look at where coal is found on Earth. Anywhere you see this little icon, we could have found coal deposits. Now let's think about this. Coal forms from tropical plants, yet it is found in Antarctica, in northern Europe, northern Asia, the southern tip of America, Africa, and Australia, and northern United States. These are non-tropical climates, yet they have coal which is evidence of past tropical climate. And so, this, just like the glaciers suggest that the continents have moved over time, and that becomes evidence number four, the paleoclimate data. So with these four pieces of evidence, Wegener published his book, The Origin of Continents and Oceans. But the sad part is that Wegener haven't proved how or what caused the continents to move. Because while he was on an expedition to find more evidences to further support his theory, he died. So this is for today, guys. Thank you for listening.